right? I'll share this PPT. Now see here, Hive with Hadoop is just demonstrated like this. So these are the different steps when you're going with Hive, right? First, you're going to execute the query. What do you mean by a query? Query means what? Query ante enti? Yes? What is a query? In DBMS, you have queries. What do you mean by query? Query is a question. So you create a question first of all, right? This query is executed. For executing this, you get a plan, right? How are you going to execute this particular query? You are going to get the plan for that. Next, you are going to put the metadata. That is, what do you mean by metadata? Large volumes of data is stored in that, and this data is sent, right? And a plan is created for this Hive architecture. So in the previous architecture, you are unable to see this one. So these are the steps which are done by Hadoop, that is using Hive. So the step one is query. Please write down that. Step one, execute query. See here, this one I'll show you there. Just now we have done the architecture. That is the first one, JDBC, ODBC drivers, right? Hive Metastore, Map, Reduce, and HDFS. So this is in detail about that architecture. So step one is execute the query. So what does this do? The user interface sends a query through the driver, right? Step two. What is step two? Get the plan. Whatever question it has sent, for that it is going to get the plan. అంత అవసరం లేదు, జస్ట్ సైడ్ హెడ్డింగ్స్ రాసుకోండి. So here you see, in the first step, it is going to execute the query. The user interface is going to send the data to the driver. From here, it is going to get the plan, and the plan is sent by the compiler. What do you mean by a compiler? What is a compiler? What do you mean by a compiler? Compiler is high level. What do you mean by compiler and interpreter? Difference. Is Python an interpreted language or a compiled language? How can you say that it is interpreted language? So what does a compiler do now? It checks the entire program at once, right? So here, even in the Hive store, you are going to send the plan to the compiler. So it is going to deal with the compilers, not with the interpreters, right? So the compiler sends the metadata. See here, it sends the metadata. First write down get plan, get metadata. Then it will send the metadata. Then you are sending the plan. You are getting the plan and sending the plan, right? From one level to another level. So the driver then executes the plan and puts that in the execution engine, right? Right on step 6, execute the plan. Step 5, what is step 5? Send the plan. Step 6 is execute the plan. Now here, see here, the main role is this one to the right hand side. So what it is doing, it is going to execute the plan, the job tracker. So whatever jobs are there, it is going to execute all those jobs parallelly, right? And then it is going to track them. It is going to put them into the mappers and the reducers. The same task is put into the mappers and reducers, right? And then sent to the data node. Now, what's the difference between name node and data node? Anyone? What is the difference between name node and data node? Who are the masters? Who is the slave? Yes. In HDFS architecture, you have name node and data node. Unda leda? Yes or no? So what's the difference between name node and data node? Yes? What's the difference between name node and data node? See, the name nodes are the master nodes, right? Which get the data from the node managers. Okay. For example, let us take a simple example. You have your principal, your faculty, and you are the students, right? Principal will execute a plan. For example, you are getting some placements or some concept. Something new is coming to your college. So who decides that? Principal decides that. That is the management. Until and unless he gets the data from there, right? Please try to understand this example. This is a query given to you, right? Then he creates the plan. He then executes the plan. That plan is given to your faculty who are called as name nodes. Name nodes, right? So these people will find out some students like your IQAC members and all those things. They become the data nodes. So these data nodes cannot do anything new other than the task given by your faculty. Clear? So whenever an outsider wants to meet you all, he has to come through your principal only. He cannot meet you directly, right? So he gives the data to your principal. All that is executed by you all, and you give your data to your faculty. The faculty in turn gives the data to the principal. Clear? So what is the difference between now what? How do you identify that these data nodes are alive? Alive ante enti? Are they working or not? I'm having 10 data nodes. So who are data nodes in this example? Who are data nodes? Students are the data nodes. Now, how should I identify that they are working or not? How will I identify? How will I know? That is your faculty. How will they know that that student is working or not? ఏం చేస్తారు అప్పుడు ఏం చేస్తారు ఆ ఆర్కిటెక్చర్లో ఏముంది ఎగ్జాంపుల్ ఐఎమ్ టెలింగ్ యూ అన్ ఎగ్జాంపుల్ సో ఎవ్రీ 10 seconds they get the heartbeat from the student. Heartbeat means he gets the response from the students whether the student is working or not. Clear? If the student is working, he will give the information to your principal. Clear? So after every 10 seconds, an image is sent, right? An image ante what work he has done, that image will be placed. Clear? In that image, again after the next second, one student sends the data. Like that, these 10 students send the data. You get an image plus edit log. If you see the architecture, you will identify HDFS architecture. You have an FS image and edit log. So that data again after 10 seconds becomes the new data. Clear? If a student is not responding after 10 seconds, the faculty or the name node thinks that this person is not alive, he is not working. So immediately he replaces another data node in that particular place. Clear? So what does this metastore do? It is going to store your data everywhere. Clear? It is going to store the data everywhere. If one of the node center is not working, immediately it will become another node center becomes active. Clear? Parallelly, how many data node centers can be alive? Have you all seen the architecture of HDFS first of all? HDFS architecture చూసారా చదివారా లేదా HDFS architecture? No. Second unit to third unit లో ఉంది కదా HDFS Hadoop distributed file system. You remember the architecture or no? Say something. Have you understood what example I gave you? That is the architecture of HDFS. Is that clear? Similar architecture. You have a manager, you have a name node, you have a data node, right? So in the right hand side, whatever data is sent by the data nodes are stored in the form of FS image and edit log. Edit log ante first I get an image, right? After 10 seconds, all these people will send the data. So this edit log and FS image will be sent again down after 10 seconds. Clear? If any of them one is not alive, what will happen? After every 10 seconds, if any person is not alive, immediately a data node becomes active. Clear? That is done by the name node. Fine. So all this data is stored in a meta store, right? So this meta store will be duplicated. And 3 times data will be stored in different places. Clear? Now your college is there. This is one location, that is one location, and the other one is the other location, right? So the same data, how many students are there? The data is placed in 3 places. Even if one data crashes, the server crashes, immediately one other server becomes active. So every time 3 data centers should be alive to keep the data in it. Clear? That is called as HDFS. So in this Hive also you are having name node and data node. You have a mapper and a reducer. So what does Hive do? Hive is going to use the drivers to send the plan, get the plan and execute the query by using all these tasks. Clear? Write down step 7. Write down step 6 is execute the plan. Execute the plan. Just write down this one. Execute plan is sent. Execute plan is sent. Step 6 is important. So please write down that. Execute plan is sent to the execution engine. Execute plan is sent. Hello. What are you doing? Execute plan is sent to the execution engine by the driver. By the driver. Under that you write down to execute the jobs. To execute the jobs. Second one under that, the job is done. The job is done. And the third one, DFS operations. DFS operations. What are the different operations done? There are aggregation operations, filtering operations. Filtering is done, aggregation is done. In UML you have OAD unda, object oriented analysis and design. Subject unda, and aggregation unda, aggregation function. Leda OAD leda. Next, step 7, fetch the results. Step 7, fetch the results. Step 8, send results. Send results. So here, please write down that result is transferred. Result is transferred to the execution engine. Is transferred to the execution engine from the driver. From the driver. When the result is retrieved. When the result is retrieved from the data nodes. From the data nodes to the execution engine. To the execution engine. To the execution engine, it returns the result. It returns the result to the driver. To the driver and user interface. To the driver and user interface. Now just see this one once again. So you are having a user interface, right? That is the user and the system interact with each other, right? So this interface, from this I'm going to send the query, right, to execute the query. Right, from here, then you're sending the query to the compiler. The compiler converts by checking that program, right, and it sends the query to which one? The meta store, right? The meta store in turn sends the data again to the compiler after taking the required data from the meta store. Then the compiler is going to send the data to the driver. Then the driver will send the data to which one? See there on the top, you are having an execution engine. So what are the different execution engines we told in the first diagram? You're having thrift drivers, ODBC drivers, and JDBC drivers, right? So these execution engine will send the data to the job tracker. So a tracker tracks whether the job is done or not. Clear? Then this job tracker is going to execute by using the mappers and the reducers. Fine. Again, then you're having the name node and data node. So these two are used in HDFS, which work like the example what I gave you. Clear? Then it is sent, the complete data is sent to the user interface. The output is sent to the user interface. Yes. Next, write down the big data frameworks. Please stop talking. Write down the big data frameworks. The frameworks of big data. See, this is important. Stop talking, please. Frameworks of big data. That is Hive. While going, I'll take 2 or 3 mobiles with me. I won't return it if I find any mobile outside. Clear? Write down the different frameworks. One is Hive, one is HBase. Then you have Kafka, Spark. There are many more frameworks, but we only study all these things. These are important. Okay? So just here, what is a pig? Right? Pig ante oka framework, right? So why did we get this name called pig? So here, the person who has developed this big data, right? When he was working on this platform, he was That is, he was in between animals. So he has given animal names. Hive ante enti? Beehive, right? Like that, he has given different animal names to it. Fine. So here, just write down, pig is a high level platform. Pig is a high level platform. Pig is a high level platform or a tool which is used to process large data sets, which is used to process large data sets. Now let us see the architecture. See here. First of all, see, this is the architecture. I'll show you the architecture. First, let us complete this one. Write down, it is an open source. What do you mean by open source? It is freely available. You can access it freely, right? Like XML, it is a scripting language, right? Yes. It was a disturbance. Please be quiet. It is a scripting language. So this language was introduced by Yahoo. Okay. So here this pig will provide you abstract data which is more efficient than MapReduce. Okay. It provides you abstract data. Pig provides abstraction over MapReduce. The two main components of pig are the first one is pig Latin language. Pig Latin language and pig execution. So what is the difference between the Java program, that is MapReduce, and pig is that if you write 200 to 300 lines of code in Java using MapReduce, you can write the similar program in 10 lines using pig Latin language. Okay, so pig is a scripting language. Now here, the difference between pig and MapReduce. MapReduce and a Hadoop MapReduce, right? So just write down that pig is a high level data flow control. Pig is a high level data flow control tool. High level data flow. While MapReduce is a low level programming language. While MapReduce is a low level programming language. So to the pig you write down, need not write complex programs. Need not write complex programs. To the right hand side, you write down, need to write complex programs using Java or Python. Need to write complex programs using Java or Python. Next one. So pig has a built-in support. What do you mean by built-in support? A simple example can you all give? Built-in ante enti? Mana mobile use chese cheppandi. What do you mean by built-in? Huh? Built-in. Built-in ante enti? For example, you are using your mobiles. Can't you say a simple example for built-in support? Siri. You know Siri and is it a built-in for everyone? If normal phone తీసుకోండి, OS, iOS తీసుకోండి, Apple phone తీసుకోండి, ఏదో ఒకటి తీసుకోండి. Right? What are the built-in supports provided by all the mobiles? System settings అది ఒకటి. You have a message. You have contacts. Do you download them? Separate గా download చేస్తామా? No. That is called as built-in. ఓకేనా? ఇప్పుడు మనకు వాట్సాప్ కావాలంటేనే డౌన్లోడ్ చేస్తాం. Right? Now here take these two examples. Pig will have built-in support to perform different operations, while MapReduce need to download all those operations and then perform the task separately. Understood? ఇప్పుడు మనకు ChatGPT ఉంది, రైట్? ఇప్పుడు మనం ప్రోగ్రామ్ రాయడానికి ట్రై చేస్తుంటాం. It will automatically give you the answer. That is called as built-in support. Now when you write a Java program, you don't have that option. You need to put all the standard input output functions. You need to install the constructors, all the drivers, right? So it takes a lot of time and it is complex than this one. Clear? So here, right on. Pig has built-in support for data operations like joins, filters, ordering and sorting. Now what do you mean by joins? In DBMS we have joins. Joins unnaya? Yes. What are the different types of joins? How many joins are there? Chappali. What are the different types of joins in DBMS? Joins చదివారా? అందరు DBMS పాస్ అయ్యారా ఇక్కడ? Joins అంటే ఏంటి ఇప్పుడు? Two different tables ఉంటాయి, right? How do we perform joins on those tables? You have outer join, inner join, full outer join, full inner join, left join, right join, right? You remember all these things? So here also we are going to perform those joins. Joins and you need to talk about them. Is that clear? So the different joins which are there in DBMS are the joins here. Clear? Next, what are the different filters I told you just now? Filtering operations and enti? Aggregation functions. We need to do aggregation functions when you are using filters, right? Next, what do you mean by ordering? Order. After one task, you need to go to the next task in a sequential fashion, right? Next, you're going to sort whatever is done in pig. Clear? Again, I'll ask you later, what is pig going to do and what is MapReduce going to do? Remember that. So it has different data operations which are built in, like filters, joins, next what? Ordering and sorting. These are the operations which are performed by pig, which are built in. Clear? Coming to MapReduce, right on. Performing data operations. To the right hand side, right on. Performing data operations is a very big task is a very big task in MapReduce. Is a very big task in MapReduce. Why? Because MapReduce does not have any built-in functions. It has to install all the JDBC, ODBC drivers to write a simple program. With Java program, right? It will take you a lot of time to write a program, whereas in Pig, it does not take you a lot of time. Simple example, ChatGPT. You start writing a program, it will give you the answer directly. మీ ప్రోగ్రామ్ రాసేటప్పుడే మీకు రైట్ సైడ్లో ఏ లైన్లో ఏం వస్తుంది అనేది వచ్చేస్తుంది. If you have used that, you will understand that. Next, write on. Pig. Pig provides nested data types. Pig provides nested data types like tuples, comma, bags. We will discuss this in the next slide. Like tuples, bags, and maps. To the right hand side, write down nested data types. Nested data types are not there. Nested data types are not there in MapReduce. Nested data types are not there in MapReduce. Yes, write on. Pig can take. Yes, please write on. Pig. Put on side heading pig. We are only talking about pig now, right? Write on. Pig can take any type of data. What are the types of data? Chapali. Tuple. Is that a data? Types of data. Simple, I'm asking you. What do you mean by types of data? Structured data, semi-structured, and unstructured data. So pig can take any type of data. That is structured, semi-structured, or unstructured data. అయిపోయిందా? Next down, it is easy to learn. It is easy to learn, easy to write, and easy to read. It is easy to learn, read, and write, as it uses data flow language. As it uses data flow language. Next, write on. It has extensible user defined functions, like Java, Python, JavaScript, and Ruby. So these are all different types of languages it supports. Yes, girls. So here we talked about high level implementation, right? Whereas MapReduce is low level implementation, right? So what is high level implementation? Just see there. If you are going for Twitter database, you know what is a Twitter, right? So from there, the HDFS, the data from the pig will go in the form of tweet tables and user tables. So how many tweets we are going to give? Tweet means what? Is it a poll? See, for example, I have placed a video in my Twitter account, right? So how many tweets we get? How many people will get likes? Sorry, how many people will send likes or dislikes or any other type of comment? So it is going to give you the tweet table and the number of users. So here it will identify how many users have viewed that particular message. Clear? So example add on Twitter data, Twitter data, example. So the different data taken from Twitter is read on tweet from Twitter, tweet table. You're going to take two types of tables here, tweet table and user table. Tweet table and user table. Next, this data is sent to HDFS. This data is sent to HDFS. So this HDFS will load the data into the pig. So what does pig do? It is going to transform this data by using the different operators, right? And then, right on, processes the data, processes the data, and stores the result back, and stores the result back on HDFS. On HDFS. So this complete is called as high level implementation, right? So here you're going to send the data in the form of tables. Clear? You need to remember this diagram, right? Last rows. If you are not interested, you can go, please. అయిపోయింది ఇది? Yes or no? Now here, just see. You cannot draw this diagram, just note down the points here. So how it is going to flow? Yes, stop talking. Last rows, please be quiet. So this is the detailed implementation of that flow diagram, right? So how the data is going to flow? Please write down Twitter database, Twitter database. So here, how are you going to divide the data? You are going to have tweet table and user table, right? So two tables are there. Yes? Now stop talking. So here you are having two types of tables. One is user table and the tweet table, right? In the previous diagrams we have seen. Next, coming to the down, you are going to import the data into HDFS. You are going to import the data into HDFS. See, take down this example. Yes. Now I'll call one of them to explain this here. First, take down this example. I'll tell it, you write down. This example is important for you. Write down tweet table and user table. Two tables you put them. So in the user table, just put their IDs and their names. Put their IDs and their names. So the number of users, you can write 1 to 10. Just put on 1 to 10 and some names. Right? In tweet table, the same user ID will come here. Whatever he has tweeted. Whatever he has tweeted, a same person may tweet the same some data multiple times. Clear? Next, you are going to import the data into HDFS. Write down. Import. Import the data into HDFS. The same data will be imported into HDFS. Next, you're going to load the data. Load. To the right hand side, you go down, write down. Load the data. Then the next step is grouping the data. Load, then group. Next. So in this group, you're going to join and group them. Clear? Join plus group the data. Next one, go to the top, write on. After join plus group, you are going to load the data into bag. Just now we have spoke about bag tuple, right? So what is a bag? To the right hand side. Write down there, user ID. Here, the user one, that is some person X, has given multiple tweets. So you are going to put the same data into the bag. Clear? One has given hello first time, second time user one has given hi, third time he has given bye. So the same person with the same user ID is going to give so many messages. Clear? Like that, how many people have given duplicated data or repeated information? Then that is going to be put into the bag. Clear? Next, what do? You perform count or aggregation function here. Here, just see. Can you see here? The same person, he has given multiple tweets. After that, you're going to put it into count. Count is equal to, just write down, count equal to, count equal to, for each, count equal to, for each user group, for each user group, generate count ID. For each user group, generate count ID. Next, Go to this side. Yes, please write down this one. Yes, settle down first. All of you be quiet. We have done the count, right? Here, we have done the count function. So count or aggregation function. Clear? Then this count is going to send the data. That is, here, the user 1 has given so many tweets multiple times. User 2 has given only 2 tweets and user 3 has given only 1 tweet. So here the bag is nothing but how many tweets every user has given. You're going to put them into a bag. Clear? Just write down here. Join count ID. Join count ID. Join count ID. User table. User table by ID. Then generate count ID. Generate count ID. Count colon ID. Count ID. User table, that is name and number of counts. Number of counts. Just put that example to this side. Name, count. Name and count. The one which I have highlighted there. You're having name, count, you're having J, which is 3. The second one, some other name you give, count is 2. And the third one, the count is 1. and then we store the result back into HDFS. Then the result is stored back into HDFS. Now, one of you explain what is the high-level implementation of pig? What are the different steps? Who will explain? Yes? High-level implementation of pig. What do you do first? Stand up. Not you, that fellow. What do you do? What do you do in the high-level implementation? What are the different steps? How many steps are there? How many steps are there totally? Yes? There are 6 steps. In that 6 steps, what is the first step you do? What are the tables that are created? So I said about tweet. Take some other example and tell. Yes, I'll just repeat once. Next, I'll ask one of you. Clear? So just see here. First, what you're doing here, I'm talking about Twitter database. This is an example. You can give any other example, right? So whenever you're looking into the Twitter database, I want to perform pig operation here. Clear? So what do? I divide the database. From the database, I'm going to get 2 types of tables. Okay. One is user table and a tweet table. How did I get them? Now I am a user, right? There is a video which is posted in the Twitter. Clear? I'm not talking about the video. I'm talking about how many have posted something under the video. Some comments, right? So here there are multiple people. 10 people are there. I'm posting it now, right? After 1 minute, again I'm posting some other message to that same video. I'm talking about a single video. Clear? So there are 10 people. These 10 people may be repeated or separate, not the same replicate people, or some different people may be posting the message. So when some people are posting there, they are posting some new messages every time the same person is posting there. Clear? So here what do? You create a user table and a tweet table. Hope you know you have seen this in DBMS. Clear? You create all queries. So for that you are creating a user ID and a name. Fine. So in user table and in the tweet table, the same user ID and what tweet he has posted. So this is imported. These 2 tables are imported into HDFS. Clear? So what does this HDFS do? It will perform all its internal operations. Now we are talking about pig, not about HDFS, right? Then it is going to load the data. Clear? It is going to load the data into the pig. So what is pig going to do? It is going to join and group them. That is what it is going to join the user table, user ID and tweet. It is going to remove username. It is going to join user ID and the tweet. So how many times the first user has tweeted, right? It is going to join all of them. Then it is going to separate those tweets by using count method, aggregation operations, right? So here, ID1, he has given 3 messages. The same person has posted 3 messages for the same video. Second person has posted 2 messages. Clear? After this count, so before this count, what it is doing, it is going to count and join, right? So it is going to post these data into the bag. In the previous one, we have seen tuple bag, right? So what is a bag? All the data which is given by the users, different users are posted in the bag. Clear? Next, after that, it is going to count every user how many messages he has posted. Clear? After that, it is going to give the result. How it is going to give the result? It is going to take the user ID, next the username, how many times he has posted. Clear? This result is stored in the HDFS again for next access. Is this clear? So this is about Twitter data. Fine. Have you understood this example? Sudha? Have you all understood this example or no? Yes? Now one of you please stand up. Take a YouTube data and tell me what we have to do here. There are 6 steps here. What do we do? First, I'm taking a YouTube video. Clear? Now tell me what do we do there? Fast. Who will stand up? Will anyone stand up or should I tell someone to stand up and explain? That guy. You stand up. Yeah. మీరు తెలుగులో అయినా చెప్పండి ఇంగ్లీష్లో అయినా చెప్పండి మీకు అర్థమైందా లేదా అనేది నాకు కావాలి కాన్సెప్ట్ వాట్ ఈస్ దట్ డీటెయిల్డ్ ఫ్లో ఆఫ్ అ పిగ్ ఐ వాంట్ ఫస్ట్ టేక్ యువర్ ఓన్ ఎగ్జాంపుల్ అండ్ ఎక్స్ప్లెయిన్ వాట్ వీ హ్యావ్ డన్ ఫస్ట్ తొందర చెప్పాలి టేక్ యువర్ ఓన్ ఎగ్జాంపుల్ ఇఫ్ యూ వాంట్ yes what happened ఎవరు చెప్తారు from the girls second row girls right hand side one of you stand up you stand up and explain some example fast తొందర నించోవాలి ఏదైనా ఒక ఎగ్జాంపుల్ తీసుకో ఇఫ్ యూ అండర్స్టూడ్ టేక్ సమ్ ఎగ్జాంపుల్ వాట్ డి వి డూ టేక్ యువర్ బుక్ అండ్ టెల్ ఫాస్ట్గా టేక్ ఎన్ ఎగ్జాంపుల్ ఫాస్ట్ వాట్ హ్యాపెండ్ సేమ్ ఎగ్జాంపుల్ ఎక్స్ప్లెయిన్ చేయలేకపోతే ఏం చేస్తాము ఫాస్ట్గా all of you take down one example and try to put the table fast take an example write on youtube video for that show the implementation operation of pig fast everyone has to write including the one who is standing you have to write so what's the first step we do there ఏం చేయాలి అక్కడ you are going to create 2 tables why 2 tables other than that do we get any other table there we only have the username hello ఏంది you have the username and his comment that's all ఇంకేమైనా ఉంటాయా ఆ టేబుల్లో ఉండవు right so create 2 different tables write down there first one is user table and the second one is not video comments tweet అంటే ట్విట్టర్ కదా ఇక్కడ మనం ఏం చేస్తాం కమెంట్స్ వేస్తాం ట్విట్టర్లో సేమ్ థింగ్ we call it as tweet in youtube we call it as a comment right? Comment table. So what are you doing here? Give some IDs to the user, some names, and what he has to be posted a comment. Please, everyone has to write. Sit down. And you're loading the table into HDFS. Step 1 is loading the table into HDFS. So not load, import. First one is import. Second one is loading. Load those two tables from HDFS to PIG. You're going to import, then load. Then what do you do? Join plus grouping. So how do you join and how you group them? Yes. We are going to take only the ID and the comment for joining them. Clear? Put on the table. A single table is required here. Then what do you do? You put all of the data into the bag where you're having user ID, name, and comment. User ID, name, and comment. To the right hand side, put it as a bag. Next, you're going to do count or aggregate function, right? So what do you do here? Count or aggregate, you're going to take the ID and only the count of how many times a person has posted a comment. Clear? First user has given sometimes, some n number of times, like that. Over? Next, what you're doing? You're posting it as a result into HDFS meta store. The same table is posted into the HDFS meta store. So see here, this is again in depth about that diagram. So we have already understood what you have done, right? Now this is the architecture of pig. This is important. Please take down this architecture. Just now we have discussed about HDFS. From the HDFS, see it is in down. Just put it down only because you're going to send the data again to the HDFS, right? So write down this one, pig Latin scripts. Pig Latin script. To the last, can you all see this one? Yes, check down the diagram. The first one is pig Latin script. Then you have a grunt shell, shells. Where do we use shells? In which operating system do we use shells? Yes. Where do we use shell? Shell scripting ekkada use chestam? In which operating system do we use shell scripts? Linux. Yes. What is the symbol? What is the symbol there? Linux lo ఏ symbol use చేస్తారు shell script ante? C bash. C back. Bash shell అంటున్నావా? Okay, you use bash shell. We can use dollar also. Okay. Fine. Write down grunt shell. To the right side you have server. So there when you use bash shell, here you use grunt shell. Right? You need to understand this here. I'll explain this one. You're having grunt shell. Grunt shell means what? Now when pig is eating, what does it do? You have to understand that same example. Pig is eating some food. What does it do while eating? It is going to chew the food, right? దాన్ని గ్రంట్ షెల్ అంటారు. ఆ డేటాని మొత్తం చిన్న చిన్న పార్ట్స్ చేసి ఆ షెల్లో డేటా అంతా స్టోర్ అవుతుంది. When it is eating, grunt అంటే ఏంటి? It is going to bite the food. When it is biting, it becomes into smaller pieces, right? All that data pig takes into it. That is called as grunt shell. And you have a server there. Then you send the data to a parser. What do you mean by a parser? Parser. Where do you find parsers? In C. CD. What is a parser? Parser ఏం చేస్తుంది? Parse tree generate చేస్తుంది. Do you remember parse tree? Yes, left recursion parser and right recursive parser. So that parse tree is generated here. Right? It parses the data, checks for them syntactical errors or semantical errors there. Next, it optimizes the data. What do you mean by optimizer? Optimizer means what? The last data is minimized. Optimizing means what? In smaller amount of program, you're going to get the output, right? It is optimizing, optimizer. Then what it is doing? It is sending the data to the compiler, then to the execution engine. Then this complete data is sent to the map reduce, then to the HDFS. That is Hadoop, right? So this is the architecture of pig. Now one of you tell me what is the architecture of pig? Architecture of pig. చెప్పాలి అది చెప్పకపోతే ఆ చార్జర్ నీదేనా ఎవరిది చెప్పు ఇప్పుడు చెప్పు ఆర్కిటెక్చర్ ఆఫ్ పిగ్ చెప్పు what are the steps in the architecture of pig? First, what do you have? Yes, yeah, be louder. Yes, what do you mean by that? Hmm. Hmm. Then. Hmm. Then. Hmm. That's all. Have you understood the architecture of pig? Pig Latin script. For example, sit down. For example, simple example you take, right? You are writing Hello World program. Okay, na? Hello World program you are taking. Right? How do you write Hello World in C? Yes. How do you write Hello World program in C? Hash include stdio.h. You take main and print the hello. Just you are going to print hello, right? Similarly, here this is called as a script. Script means what? A scripting language. So pig Latin script you are having. Then what you are having? That script is sent into the grunt shell. What is a shell? I told you. Shell అంటే ఒక just a small space where you use a bash shell or a grunt shell or a sea shell. Okay, here we are using grunt shell. Grunt shell nothing but the pig is eating food. That is the program what pig is going to eat. So when it is chewing the food, that is called as grunt shell. It is going to divide the program into smaller parts. Clear? Then from the server it is going to get some program. That something like hash include stdio.h. It is a built-in header file. So from there it is going to take that hash include function. Here we are not talking about hash include. I'm talking about some example. Clear? We are not using hash include here. I'm giving an example what you understand. So I'm taking the server from the server some data. Then what am I doing? I'm sending this program to the parser to check whether it is correct or not. So what does the parser do? It will check for the syntax, semantics. Semantics means what? Syntax and enti first of all. What do you mean by syntax? Is it grammar syntax అంటే ఫర్ ఎగ్జాంపుల్ ఇప్పుడు మెయిన్ రాసాము రైట్ మెయిన్ ఓపెన్ క్లోజ్ బ్రాకెట్స్ ఇస్తాం కదా ఒకవేళ అది నేను మర్చిపోతే దట్ ఇస్ కాల్డ్ as syntactical error. Clear? Semantical error means what? If you have written some grammar mistake, now I want to convert implicit conversion int to float, float to int. Okay na? A conversion చేసేటప్పుడు some error I have given there, some mistake I have given. That is called as semantic checking, right? Semantic error. So this parser will convert that program into a parse tree internally. Parse tree అంటున్నాను. Parse tree. You are given e derives e plus t. Do you remember that? దాని ఒక పార్స్ ట్రీ లాగా జనరేట్ చేస్తారు కదా ప్లస్ వేసేసి గ్రామర్ వేసి ఇట్లా సేమ్ థింగ్ విల్ బి జనరేటెడ్ హియర్. Then it is sent to the which one next? To the compiler to compile that program whether it is true or not. Sorry, not compiler, optimizer. Optimizer, what it will do? It will optimize the code, means minimize the code without any error. Then it is sent to the compiler to check the program which is written is correct or not. Clear? Then it is sent to the execution engine. Execution engine అంటే ఏంటి? ఇప్పుడు మనం సి ప్రోగ్రామ్ రాసే ./a.out అని ఇస్తాము. అక్కడ మనకు అవుట్పుట్ వస్తుందా లేదా క్లియర్గా. Clear? That execution engine will execute that program to see whether it is correct or not. Then the program is sent to the HDFS. Map reduce, then to the HDFS. Clear? This is the architecture of pig. Fine? Next. So here you write down this one. Pig components. ఆపేరా ఆపేమన్నారు. Yes, write on pig components. All of you. Yes, stop talking. Write on pig components. Here you are having the two components are pig Latin and pig execution. Pig Latin and pig execution. So already we have done pig Latin, right? The same thing. You're doing a series of operations or transformations there. In pig Latin, we are going to do a series of transformations and operations. Next, a pig execution. There are three executions here, execution engines here. One is script. Please write down that. Script contains pig commands in a file. Contains pig commands in a file. It is saved as .pig. It contains pig commands in a file saved as .pig. Next you have grunt shell. Grunt shell. It is an interactive shell. It is an interactive shell for running pig commands. The third one is embedded. Embedded. For provisioning. For provisioning pig script. Pig script in Java. It is providing a pig script in Java. Next you can write down. You can run Apache pig. You can run Apache pig in two modes. In two modes. The first one is map reduce mode. In two modes. The first one is map reduce mode. This one I write down. This is a default mode. This is a default mode which require this is a default mode which require access to Hadoop cluster and HDFS installation The input and output in this mode are present on the HDFS. The input and output mode are present on HDFS. So here we require the command called pig. You enter pig and enter it, it will run internally, right? The second one is local mode. Under that you write down with access to a single machine, with access to a single machine, with access to a single machine, all the files with access to a single machine, all the files are run using a local host, a local host and a file system. Here the local mode, here the local mode is specified using -x flag. In brackets you write down, you need to give pig space -x local to run the local mode. Pig space -x space local. The input and output, the input and output in this mode, the input and output in this mode are present on the local file system, are present on the local file system. Next, write down data type models. What are the different data models you are going to get? Data model types. The first one is an atom. How many types of data models you are going to get is the first one is the atom model. The next one is a tuple. Next is a bag. And the next one is the map. Yes, stop talking. Now write down the difference between a tuple and a bag. Write down a tuple and a bag. Just put down this diagram. So here you are having serial number, right? Serial number, the brand, then you are having the members and the origin from where they have come. That is from where they are tweeting the data. So these attributes or the fields are called as the tuples. You know what are attributes? What are attributes? Define an attribute. Attribute means what? The details about a particular person or a particular entity. Clear? So the serial number 1, his band, number of members there, from where they have given this message, right? And their origin. Who is that? And bag means nothing but these details. Columns are called as tuples and rows are called as bags. Please separate them. Tuple and a bag. Over. Now the difference between a map and an atom. Please stop talking. Yes, a map and an atom, right? What do you mean by a dictionary? You have done Python, right? Key value pairs are called as dictionaries. Here we call them as maps. Here, write down that atom and a map. Here write down map is a key value pair. A map is a key value pair used to represent. A map is a key value pair used to represent data elements. Used to represent data elements. Example, take some serial number. 1 or 3, anything like that you take. So serial number is a key and value is 1. Yes, last rows. Next one, write down an atom. An atom, you can take down that example for key value. Next, write down atoms are basic data types. Atoms are basic data types. Like the data types which are used in different languages. Atoms are the basic data types like the data types used in different languages. What are those? You're having int, float, char, long double, double, right? Yes, do you have char data type in Python? Yes or no? Yes? No or yes? క్యారెక్టర్ డేటా టైప్ పైథాన్లో ఉందా లేదా? దాన్ని ఎట్లా రిప్రజెంట్ చేయాలి? క్యార్ వచ్చేసి సిలో ఉంటుంది, పైథాన్లో ఎట్లా రిప్రజెంట్ చేస్తారు? స్ట్రింగ్. క్లియర్? సో దీస్ ఆర్ ద డిఫరెంట్ డేటా టైప్స్ విచ్ ఆర్ అవైలబుల్ ఇన్ ఆల్మోస్ట్ ఆల్ ద లాంగ్వేజెస్. Here, these are the operators which you need to know. You will get this question. Explain pig operators. Pig operators. So write down just those operator names. I'll share this PPT with your faculty later. You can take down. I have given a question and answer for every topic. Word file only. I will share it. So the different operators used for pig are, the first one is load operator. Load. Next, for each. The second operator is for each. Next one is filter. The next one is join. Order by. Join, order by. Next, you are having store, distinct, store, distinct, group and co-group. So these are the different operators used by pig, right? To perform pig operations. See, these are all these things. Just now I told you, you already know what are the different types of joints, right? You're having inner join, outer join, left outer join, left inner join, right join, full join, and self join. Clear? So about them, these are the examples. So here what you are giving, I'm using the grunt shell and I'm performing these operations. Rather than in C shell or bash shell, I'm using a grunt shell. Just take down this example. This one, grunt greater than. Yes, please take down this. Take down this one. Stop talking. Yes, please be quiet. Take down that one. You're taking the grunt shell. Take down that joining of that one using the grunt shell. Yes, completed. Did you take this one? This query you have taken? This one. Grunt shell relation tree name. The last row is be quiet. So these are all the things. How do you create a file system and all these things? These are the commands which are given in the pig architecture. You should do it when you're installing pig. Clear? All these commands are required. See, all these are given. Next, write down. See, we have done the different operations. What is the use of trim operation? Write down trim function. You have to do all these things in your lab. How do you install it and all that? Write down trim function. Trim. What does trim do? Trimming means what? Yes, it either removes the left hand spaces or the right side spaces, right? It is going to reduce the size. Whatever unwanted data is there, that will be removed. Unwanted data means spaces. Clear? So write down the trim function. The trim function accepts a string, accepts a string and returns its copy after removing the unwanted spaces after removing the unwanted spaces before and after it before and after it. Just write down this one. In the grunt shell, you're going to give trim and an expression. Some string, whatever you want to trim it. Right? Write down. Grunt greater than. You give greater than. You need not give it is by default. Right? Grunt greater than trim in brackets expression. Take down this one. Grunt trim data. Grunt trim data is equal to for each employee underscore data. For each employee underscore data, generate in brackets ID comma name comma trim name. So you're having ID and the name, you're only trimming the name there. Take down left trim. L trim means left trim. It removes this unwanted spaces. It removes the unwanted spaces from the left side. It removes unwanted spaces from the left side of the given string. For that, the command you give it as grunt greater than L trim, grunt greater than L trim underscore data, grunt greater than L trim underscore data equal to for each employee underscore data generates in brackets ID comma name comma left trim name. Similarly, write for right trim. The same syntax you have tried on. Yes, completed. You have done left trim and right trim, right? Right trim అయిపోయిందా? Please write down right trim. The same command. Write down the right trim. Next, go to the Hive. Write down the services of Hive. What were the services of Hive? We have seen in the first diagram. Hive services. In the first diagram, you have seen the services of Hive. Hive server, Hive services. Write down the Hive services. The first one is B-line. B-line. Next, you are having the Hive server. Hive server. 2 is not required, leave it. Hive driver. Next, Hive compiler. Next, you have the optimizer. Next is the execution engine. Execution engine. Next, you're having the meta store. Next, you're having the Hive catalog. Hive catalog, H catalog. H means Hive. The next one is Web Hive Cat. Web Hive Cat. So these are the services which are provided by Hive. Now just let any one of you explain this diagram. Who will explain this diagram? Hive architecture. Who will explain? Already we have done this one. The second diagram. Just see the diagram in your book. ఈ book లో ఉంది already. చూడండి. I said the 7 steps, I think. 7 or 8 steps. Just see that architecture because we need to start hedge base. Yes, check the diagram. Yes, can you see this now? Yes, stop talking. కనిపిస్తుందా ఇప్పుడు? Can you see the diagram now? The last rows, can you see this diagram now or no? Huh? Yes or no? You are unable to see it properly. Yes, stop talking now. Yes, settle down. Write down the next function. Upper function. Yes, stop talking. Write down the different function. Upper function. Zoom రావట్లేదు. Write down the upper function. Upper function. Under that, write down this function is used to convert. This function is used to convert. Upper function. This function is used to convert all the characters in the given string, all the characters in the given string to uppercase. Write down the command grunt greater than upper and a given expression. Next, grunt greater than upper data. Upper data, that is uppercase data you're going to convert. Uppercase data, upper data. Equal to, for each employee data, for each employee data, generate, for each employee data, generate, in brackets write down id comma name, id comma name, comma uppercase, upper in brackets name, upper in brackets name. Next, write down lowercase function. The same thing write down as a lowercase function. Write down the syntax of the lowercase. Write down the syntax of that function for lowercase. Lowercase. Yes, stop talking. అయిపోయిందా? Next, replace. You're going to convert the string to uppercase, then lowercase, then you're replacing the string. You're replacing the given string with some new character. So here I'm replacing the city name from that string to a part of that string. Write down that one.